welcome back to another video. So I'm starting to work on some new stuff after my latest release. So one thing that kind of came up when I was just tidying stuff up was when you do too much of you get a stack trace panic after a while. So the reason why that was happening was if we look at SDD level, I think it's in. So there's a malloc, and that can only go so much. So say if I have 5 times more stuff, now we just have a boot loop type thing, so it's just constantly restarting. And if we say only double it, I think it gives a slightly different one. Yeah, so now it still works. So we're kind of running out of memory, but we're also not using memory the same way. So yeah, we can have between 2 and 3 times that amount. But in reality, this is not the best way to do it. So we're basically just having a static allocation that's kind of built into the file system, built into the hard drive. So if we look at osdev.image, without doing that, so if we don't do this truncate stuff, and if we just build it again and look at this, so we've kind of got 300k, we can do an H there, 350k of disk that we're using up. So, and when we go over a certain threshold, that's when it, not that one, so say if we do times 3 there, and run that again, now we've got 860k. So that's basically just making a part of the data that gets loaded from the hard drive into static memory in a way which isn't really the way you meant to do it. So if we look at boot includes IDT, not IDT, what's the one? Is it just BIOS? Yeah, I think it is. It's probably not the best place to do it. Yeah, so we have this read sectors, disk read, that's what we call from, so this is called from, not that one, look that and not that, yeah, so this is called from the real mode part, and where do we do it? Yeah, we call this disk read, and that goes into, and that's right before we go into the 32-bit mode. So we load a global descriptor table, and we set the predictor mode bit, and we basically do a long jump into the second sector, which is just down here, which in reality will be the boot32 file here, so it'll basically be here, which, we don't even need this anymore, because we've got debugging stuff, but anyway, that's another rabbit hole to go down. So this disk read, what it does is it looks for this magic offset. Now how it gets that magic offset is, we'll get rid of, actually no, we'll load it up again at some other point. Up the top of boot, so this all gets loaded at 7C00, So this line here will be at 7C, which is kind of how MBR works, master boot record. I think I did a video on how that all worked. But yeah, so here we kind of have this magic offset, which is like real hacky. Basically, so this boot is a label at 7C00, and we have like a constant just to make it look better, add 5 bytes, which this instruction here will be 5 bytes long, and then we basically have a word for a pointer to magic, and magic is defined in the book 32 and part of the magic section, and it just has a magic value which I kind of made up, and that is using the linker. So here we start at 7C00, that's where the boot code is, so right at the start, but then the magic is right at the end. So theoretically, the end of the disk, which we can kind of see actually if we look at tools at build osdev.image. So if we look at the bottom of there, it's got like a bunch of other stuff. What was the value we were looking for? It was like, I'll probably remember if I see it, 32, A, B, C, D, E, F, yeah, but it'll be like in reverse order. Yeah, so it should be after all of this stuff. No, I'm not really seeing it. These GNU things are part of the kind of C library. Yeah, so I do wonder if it's actually not loading in the right place. This is probably the malloc space, all these zeros here. In fact, yeah, we can change that back because I don't really want it to be crashing out all the time. That'll confuse me. Yep. Yeah, so now all this there is the malloc space. So there's a bit of stuff. And then there's like some strings. Now I want to find this magic value, which I guess I have to just search for, I don't know, BC. Let's search for BC. And search up for it. Is that where we're looking? No. No. Oh, I'm like kind of worried that it's not actually at the end of the disk, which could be. What we could do is, if we do magic as, I think we'll do it. Actually, no, I won't do it that way. I'll just do db. Learn to spell. Where's my M? Yeah, we'll just do like that a few times. And now if we just search through, yeah, so that's where our magic is. So yeah, there's the 1A, B, C, D, E, F9, so it's kind of backwards. So searching the BC, I probably did see that, but yeah, and then at the end we've got all these magics. These GNU things are like from the, if we go object up, we've lost that. We'll just not remove the objects. And run that again. So if we do this, except don't do that. yeah, read elf will do the trick. And yeah, so if we do this, we've got this kind of these GNU specific things, which that is what is happening. Yeah, basically the stuff is we've got extra sections that we don't kind of talk about in the linker, so it's not there, which I think there's potentially a flag that we can do to disable it, but I'm happy not doing that, I guess. But anyway, what I wanted to do was work on getting proper memory. So if we run this, yeah, so it still works. So proper memory, it's something that we haven't really done. We kind of just assumed that we have unlimited memory, and we have a yeah, we just use static memory for pretty much everything. So on the osdev wiki, which is a pretty good resource, there's a couple of pages that are useful for memory. So first is like a memory map, and I think what might be happening is like, yeah, that's the real mode one. Yeah, this is probably what we want. What I have a feeling is we are kind of overriding what is happening. So what I might do is just do like very hacky. Yeah, so after we do the init and we do the auto start, what I might do is just call printf of some string and we're going to pass in the malloc heap. Might be able to look up where it is. Std lib. Yeah, that's cool. Malloc heap, which isn't public, which we'll just make public for now. Malloc heap, and we'll define that and malloc heap plus malloc cap. Yeah, and we'll just do the malloc str here and db malloc heap is from, and we'll do a what am I doing? Pointer to pointer and do that, except do proper thing. Yep, that's kind of what we want. So now if we run this boy, except we need to also extern malloc heap. Alright, so now if we run this, yeah, so it will say where it's from. So we're kind of using up all this memory, and we can have a look to see whether this kind of exists. So C0E8, I guess the high end is the important one, so 4 in the 5th column. So does this have anything? Yeah, so I would say that we were potentially going over this threshold here, which we can do some testing. So times 3 broke. So this isn't actually what it is, so it shouldn't crash, yeah. So CC0, so that is like all the way up there. So we're like kind of overriding all of this. So that's no good. That is probably why we're crashing. Like we're just overriding the display memory. Yeah, so what I want to do is, now that I've kind of worked out, yeah, we can only really go up to, I suppose we could set that as like our max, but where do we start? C. Yeah, so that's where we start, and then we can go up to this point here. Yeah, so I guess for now, what can we do? We do a kind of similar thing in boot 16. Yeah, so this like dollar. So I think we can do something like that. Can we like define it based on this? Yeah, I wonder if we can just do something like that. We'll give that a run. No, we can't do that. I think I'm like trying to just shave too many yaks. What I really want to do is kind of investigate getting actual memory. So working out how much we have, and that way we can go beyond this data, because that only gets us like 500k, which just isn't really enough for, isn't really enough for like lots of stuff. So what we really want to do is kind of have this extended memory, which we can have above a megabyte. In fact, we can have up to 4 gigabytes, just the way that we're using the system. Which there's this page here that kind of talks about it. If we want more than 4 gigabytes, we basically need to use this PAE or long mode. Long mode is the 64-bit. So we could potentially set up PAE at some point in the future, but at the moment we don't really use paging, which is a small issue. Now, which one is it? E820. E820. Yeah, so this one here is like the function that we want to call. So this is a BIOS function, which means that we need to do it from real mode, which brings up another small issue. In that I might just kind of clear this stuff and clear that. Just make sure that we don't have anything. We can delete that and this string here. And boot 2, yep, and down here we'll just get rid of that. So, in our boot code, which will load up boots, so in boot 16, we do a check, and we kind of display where we are. So the way it works is our first sector, so the first 512 bytes of this entire operating system gets loaded in the memory at this address here, 7C00. So basically your OS boot sector. So I've got a boot sector, it's doing some work. Now if we go tools, build, and scroll back up to, in fact, let's just go faz where's the source boots? Yeah, that one there. So when we compile this, we can go up to this byte range here, and you'll see that we go up to one less. So we basically have 1 byte to spare in that first sector. So what could happen is we could not actually go to protected mode here. So we could move that stuff down to here, and this can just be our second sector. And here, instead of jumping to the second sector, we can jump to predicted mode, and we'll just set up a predicted mode here. And so at this point here, we just want to do a normal jump to the second sector. Now I might try run this, just see if it still works. It still works, cool. So what that means is we could either try and squeeze out more bytes and make it all fit in 512 bytes, which, I don't know, that could be a kind of fun exercise. It's quite large because I add like a bunch of stuff, like, so I guess this is needed. This uses, 4, 6, 7 bytes to kind of say some stuff. That could be that to be a bit, that's like 3 bytes and that's 2 bytes, I think. So like there's ways we can kind of speed stuff up, and then we also like have a lot of error detection. So we call this function, and that function itself has includes that's an A20. Not that one. A20. Yeah, so this also kind of does a bunch of comparisons to basically check whether everything is all good. And then this also, I don't know, like there's probably spaces that we can do. And we also kind of have a bunch of static strings, which I think I went at one point and shortened these all down just so I could squeeze it below 512 bytes. But yeah, anyway, we'll do this. Yeah, we'll move that there. And this, we can, so I guess like the disk reading, we also only really want to load that much of the disk, which we potentially load more. Like that doesn't seem like much, does it? I think I want to print out where magic is. Util shell, which I think I used to, but haven't in a while. Yeah, this thing here. Cool. So magic string db magic is at, and we'll do at 13.10.0, and here we'll call printf magic string and magic, and we'll probably need to extend magic. I believe it's already public. So now if we run this, magic is at 5e something. So it's like still in that kind of zone. So we're using less than 5 to, yeah, we're using not too many bytes, but that's something that we'll need to keep an eye on. That we can only have a bit more before we kind of have that same overflow. Which, yeah, I wonder whether we should detect that in the read function. What I might do is actually just keep that there. Max it can be is 0x 7 FFFF. Cool. Yeah, so just to I might just have that printed there just for now. Anyway, what we want to do is detect. We want to call this E820 function, which that also kind of uses a bit of code, which there was like a code example. So what I might do is just copy this for now and then see if we can adapt it. So that stores it at 8,000, which it's like just a bit above where we are. What I might do is potentially store it at like 500, because I don't know how much it's going to take, but I might copy this function comments and all. Taken from that, and then we'll copy that again and paste that in. Yep, so we don't really want to store it there. So what was I thinking? 500. Now, where do we have our stack at this point is software. Yeah, our stack is basically at 7000. Here growing down, so this area will kind of overlap with the stack if we're using it. At this point here, the stack should be pretty high up. This feels like it should actually be there. Yep, this feels like it should be in boot includes memory. That's just a issue with issue with the linter formatter I use for assembly is it will kind of add spaces where you don't want it unless it's in a string, mainly because it's not made for this assembly language, and a semicolon doesn't actually mean a comment in that one. Cool. Right, so I might do that, and right, let's just call that. Where are we looking? We've loaded too many things. So we'll include this here. So include /memory.inc. That will do the trick. And we don't want to include it here because that's kind of where it's and we just do call in real land this cool. What I might do is actually step through this bad boy. we sure? Oh, I did that thing, yeah. Yep. Format for me, yeah. That. It's like a weird thing. I don't know. It like strips off where it's yeah, it kind of just strips off what you copy. Right, so now if we go here, we can break at how do we do this? 7EOO. I think that's where we're going to be. Second sector will be 7EOO. Right, so this is going to be yep, and then we call that. Right. Do we want source boots includes memory and yep, I'm happy with that. We'll just do read only. Cool. So what we're doing, I wonder whether we need to change some of these numbers. 804. Yeah, so I feel like we need to have 2 pages of that open. Where was the link to it? Yeah, this one here. Yeah, so what arguments does this thing take? Yeah, input is, and we are trying to set a DI. Yeah, so we don't want that because we've changed this. Yeah. Oh, I feel like this code could get changed a bit. Yeah, so I suppose the size is getting stored there, but then we actually want to set that. These splice functions are a bit weird because, like, well, I suppose like most of real mode, you store it in the registers. Right, so I'll potentially like comment this up. Maybe we'll step through until we are about to kind of call. Right, at this point here, we don't, yeah, that's like one problem. Right, so PDI, yep, so that's it. That address, we'll look at that, EAX, so EAX should be E820, that sounds good. EBX is 0, yep, so it should be 0 the first time. Yep, so this pointer is not right, so we'll first look to see what PX SI was it? ES. Right, so yeah, this we want not to be there. ECX, what's that? ECX 18, so we're going to get 18 bytes. Alright, let's suggest setting it to 24. Yes, I do wonder why this is not 24. Oh, it's, yeah. It is 24. It's 18 in hex. Cool, that is the buffer size. And then EDX should be that signature. EDX doesn't work that way. We can, like just, we can do like, no, that's not the way we do it. 5.3 0x4d. So that is S map. Cool. So I think what we want to do is change that to like to be. It does use. Alright, so it does store that there. Yeah, I think what we want to do is set this to. We'll quit that. Go back here. Yeah, I'll probably tidy up this code to make it +4. Yep. Cool. Let's do that debug again. Why do we? Forgotten it. Break at that point there, and then step into that. Yeah, I forgot that. I wonder if that still works. I think we also need to do. It's been a while since I've done this real mode debugging. Choose debug .gdb init. We removed something at some point that we probably shouldn't have. Debug break equals short 0x7c09. I took this out because we don't need it in the projected mode 32-bit. But we do need that here. Reset, stop, define, stop, end, and we'll do that debugging. Yeah, because we did it here, which is needed, but if we, I'm just going to let me here we set this debug break. So that's what we're doing, and that debug break is basically that does it for box BOCH, but that command will be a break for that. But if we just do a breakpoint on it, then we can do stuff like this in 3 here. In fact, I might just do it here. Debug. So theoretically, yep. So it's set our breakpoint, and it set like another breakpoint there. So if we do like a continue, no, that didn't work. It didn't work. Is it because we don't have? Oh, I think it's because. Yeah, that's annoying. It should go. It should. But it's not. Well, anyway, we'll step into this. And we'll do a break on 0x7 E4A. So we'll just do a breakpoint just after it. After this int 15. So px di. So we're going to save it at there. And what is at that address? I think if we go export, yeah, so there's like nothing there at the moment. But once if we do like a continue, so now we got there. So there's nothing. Not the word, yeah. So there's still nothing there. Is the carry flag. How do we get the flags? It shows like here, but it doesn't in this font. I wonder if other way. Right, that shows the flags. So the carry flag is not set. So we didn't do that. Right, so what's EAX now? EAX is the same, so I'm kind of stepping through manually. So it was set. What is EBX? EBX is 1. Cool, yeah, I think oh, we have like a jump. Oh, right, so we jump from there to jump in. Now this is a function that I didn't, well, not a function, an instruction I didn't realize about. I had to look it up. but it is basically seeing what ECX is. So jump if ECX is 0. So it's not at the moment, so we shouldn't do a jump. What's CL? CL is 20. So we apparently got a that. So that did jump. Jump JBE. There was like the byte equal, wasn't it? No, it was the unsigned. Which, yeah, I don't know. I'll probably clean this code up to make it similar to the stuff I've written in the past once I understand it a bit more. So it is equal to 20, so that means we go to no text. Right, so at this point we should be looking at what is 8 bytes above. So yeah, that doesn't actually show us because it shows 1, 2, 3, 4. So 8 bytes above, that would be B. Yeah, so that's got some stuff in it, which I don't know if it did before. Yeah, so that is this kind of it's got like a format that it needs to be in. So we'll continue stepping through. So we get ECX. So if we go PX ECX, we get that byte that we saw, and then we OR it with 504 plus 12. I might just do it that way. That'd be about right. Yeah, I think that's right. And I was like 1 off here. Right, so OR it with that. So we're going to OR with a bunch of zeros, so it should just keep. So they'll set the flags maybe. So that cleared the 0 flag, so it is not 0. So we'll increment BP. This one's a lot more sticking through. So we've currently got nothing. Yep. Oh, look at that. It knows where the 32 is. We're like right there. But we're not going to make it there. Yep, I was just thinking why it was there, but that is fine. Right, so now we're going to like add a bunch more to DI. Add the 24 bytes, so now we're going to look at that. So what I might do is x-24x, I think is how we do it, and 0x504. That went too far because we just want to go, 24 bx. Yeah, and so if we do 25, that goes to 1c, which is what DI is now. Yeah, so we want this kind of thing. So there's our 24 bytes that we have. So we can see that we've got some stuff and maybe some flags there, which yeah, there's probably yes, this output. Yeah, that is what we want. So the first like 8 bytes of the base address. 48, yeah, so the base address is 0. Probably right for the first one. Then our length is, oh, that's just the next, isn't it? So our length is this, which is what we got before, and then 16. Yeah, 8 to 12 is, yeah, so 16 is just this byte here. And the address type is, yeah, this is kind of cool. So it's usable RAM and it's like that long. Which is that still like stored somewhere? 9FC, yeah, it's this one here, so it's like that long. That's like a decent amount. 600k ish. Yeah. So I guess at this point here we then see if we still have stuff. EBX is 1, so we do still have stuff. So here we just go back up to here. Right, so now we basically do the same, but we set like the 20th byte, and we've already incremented. Oh yeah, so we did that before up there. So we kind of do the same thing. So we'll do a break at 7E77. So that's our like kind of first two things. So this one has a different base, which looks like the base is just where we left off. This one has a different type and quite a lot shorter. And so what was that other type? So it is a 2. This type it's a reserved one. Right, so this one we shouldn't be touching. Yeah, so I guess the plan of action here is to load this into memory and then have something in protected mode that reads through all this data structure to work out whether things are usable or not. And like we'll kind of have like allocation of memory from a memory driver. Yeah, so we'll do this whole process again. So it does a bunch of things. ECX still has 20, so that's good. CL is 14 this time. Is that the same thing I was checking last time? Oh yeah, 14 is just the, yeah, 20 is 14 in that. So yeah, we've got some stuff. And then we get the size, so that's, we got like 1,000 bytes. And whereabouts was it? It was starting from FC 9 FC. I wonder if that's somewhere in this map. Yeah, because we're saying like that is legit, but I suppose it's like for when we got here. Yeah, yep. Right, so then we do the whole process again. So now we've got another one. Plus 24, yeah. So here we got another one. So this base address is like small 534. Yeah, that is. What do things get set to? Yeah, so bx will be whether it's the end, but it's not. I might just skip to the end. Right, so it had 6 things, and then we had all the 6 things. Yeah, so I'm fairly comfortable that is reading stuff. I think the next step is to make some stuff. Yeah, so in source, I was thinking about this before. Yeah, I kind of want to make a because this doesn't really do too much. It'll probably do some more at some point. All it does is kind of spawn a shell. But we also have like this scheduler that doesn't really belong in like the base directory, but oh well, we'll do that there, and I'll have a cleanup at some other point. Yeah, we'll probably just load that in and do all of this. We'll have some sort of structure, so I might keep that as that. What kind of memory block is this? Address range descriptor. Memory descriptor, I'll call it. Alright, so we have base low, base high. Base low, base high, length low, length high, type. How long was type meant to be? So just like 1 byte. Yes, that's just like 4 bytes. Type. That is used for this. We'll do that. Memory descriptor. Memory descriptor. That one. Oh, can you do something like that? Don't block it. That's right. No, not having more. I think it's like aligning it to this point here. At some point, I'll probably make a better thing. Yeah, what I might do is dump out this memory table. So how do we go about that? Yeah, I might just do a We'll have a offset here. Memory or base equals 0.500. Alright, enter 0, 0. We're in 32-bit mode now. Right, so we'll get the size first. So if we move ECX from memory descriptor base, and it's going to be, yeah, I believe we said it was a 4 byte. So yeah, cool. Printf size str, and we'll have ECX. I kind of wanted to push EBX here and pop EBX and make that an EBX, just because I want to keep on to that size, and ECX will get potentially disrupted. So at this point we can, yeah, let's also do ESI. So move ESI, and that can be memory descriptor base plus word size, I guess, which we do have included, but that's that. Yep, and we're going to have some sort of loop, and some sort of return. So what we want to do is test EBX, and while it is, so if it's 0, we'll jump to return. Otherwise, we will do a jump back loop, and we'll do a deck EBX and a add ESI, and we're going to add 20 to that, because we've got like 20 byte things. Yeah, everything's kind of, we're doing like 24. Yep. I think that is what we want. And here we should really do size of memory descriptor. Yep. Cool. At this point here, we can print out the memory descriptor. So I guess str db size of memory descriptor table is we can just have a normal integer. And we've got a base, a length, and a type. Or this might require some, my printf function, in fact I'll load it up, my printf function doesn't have, where is it? Yeah, we like just don't even test for it. Yeah, so I think we'll so if we go like man3 print f, can we do that? Yeah, so if we look at the printf, I didn't actually finish everything. Yeah, so what I kind of want to do is have like a long, because we have a long thing. Basically, this base low and base high will be, well, it's two 32-bit things, 64-bit address. But yeah, we'll ignore that for now. Base SG. Descript or descriptor number D. I think that will work. Yeah, I think if these two were swapped like that, would it? Yeah, it's a base address. I suppose we can just do something like that. Yeah, something like that. Yeah. Just do like a yep. And a type. And that we can just do a D. We probably could do them all at one, but I'm just wondering whether we'll have enough things to do. Enough registers, that's what I was looking at. So if we move EAX from and get the base, yeah, we'll get base high and ECX can be base low. And yeah, so first off we will we don't really know the number because we're counting down. I guess we don't need to know that. That's alright. We'll just alright, so now we want the high and low. And we want to do that again for and get the type. And just the one. Yeah, I think that will do the trick. Just do a public dump memory map maybe. Yep, and then source utils show. I mean, potentially we could memory map. I'll just do it every time. Potentially we should have an actual command that gets run, but for now we'll just kind of print it out. I didn't like it. That is because I need to make this a bit more robust, but in here, how do we do this? Scheduler, yeah, so here we're like just kind of adding manually. So if we do add memory there, or missing encode, well that's no good, is it? Like on all of them? Right, find comma, insert that, and what rookie? No print F. What we can do is lib includes an stdio. Is it really? Out of scope. That. Cool, so that's printed out a bunch of things. So we got 6 descriptors. I might term move 0, 0, and resize 80, 25, just so we can. Wow, there's like bugs. Right, so we can't quite fit it all in one, but yeah, we've got 6. So that's our length, then we start there, that's our length, then that's unusable, and then another unusable, which I wonder whether these, that is F for like a bunch. Let's have a look at this. Yeah, so that, I think 64K. So this one, I think that's the motherboard BIOS, which yeah, we don't want to overwrite that. This 9FC00, it's like not in any of those. It's like, I guess partially used, so and it only goes up 400, so that's DEF. So that will go and overflow to 10. A, yeah, so that's like just the top half of that EBDA. That was the motherboard thing. This is usable again. Then this one is not usable again. I don't really like the the high and low counts don't really show well. Because no, we would want like 8. Do that again. And move 0, 0. Probably see some bugs. Yeah, like when I scroll up once, it kind of shows that. And then I go down again, and yeah, I don't know. That's something for a different day. Right, so we don't want to pad it with that. We Remove 00 term resize 8025. Cool. That fits quite nicely. Yeah, that looks better. 1, 2, 3, 4. This isn't quite right. I'm wondering whether I kind of just say that's where my memory starts, my malloc heap for now, but I probably should do like a better thing where I know what is being used here and what isn't. So it looks like we've only got a couple of usable ones, so 2 is unusable and 1 is not usable. I think I want to add a space in here. In fact, let's have a look at this and percent p. Yes. Yep. What if we just do that? Will that do the trick? Yeah, because it can go up to like 8. I think this high byte we just don't really care about, though I do wonder what it will be on other systems, because yeah, just tools run key move and key move system. Yeah, so what if we do mem? Oh no, that'll do us the trick. Yeah, so default is like 128k, which I wonder if that's what we were seeing. But say if we did like 6G, and like try and run that. They're all different, but I guess the length is more now. Hey, yeah, so I know, let's do something like 32 gigs. Or can't it look at memory? Well, I might not have enough. Yeah, that does the trick. Yeah, so that base address, that high byte got set. Yeah, so I think, oh no, kind of yak shaving, but I think I want to set that so the high byte can be like whatevs. Yeah, so that high byte got set. So we wouldn't be able to use that because that's above the so say if we do like 5G, yeah, so that also goes over and it got about a gigabyte. Yeah, so this is 4 gigabytes here, and that goes up to 1. So if we go down 1, we still go over there. But then like there's also like kind of other memory, which I kind of read that like sometimes it won't actually, you won't include that first gig or something. I don't know. If we do 3 gig, then that, so 3 gig is usable by us, so we don't have that high bit set. 1, 2, 3, 4, 1, 2, 3, 4. Yeah. So I kind of like don't want to display all the leading zeros if there's nothing to show, but yeah, it is what it is. I'll have to get fixed another time. But I think this is probably a good spot to stop. So I think I'll commit up all of this, and next time I come to this, I'll look at assigning this memory out, and then Malik can kind of use that page rather than use static memory like it has been. I mean, theoretically we could, I'd prefer to do it dynamically. So theoretically we could go to this one, type 1. That's like, we're not allowed to use that. I'll probably take, like, say this one here, and say this is where Malik will start, and basically would allocate like some number of pages. I don't know. I guess like we could just see where the first biggest usable memory is, and then set Malik to be that. And that would have to get done like kind of early-ish on, which it could get done pretty early on. We'll have 3 gigs. It's a good test. Cool. We'll get rid of all that and see what we have. I'll add that in. Why not? Actually, what I might do first is get branch. Must be memory. Don't forget my flags. I must see. Oh no, it's good. Yeah. I'll do that again, even though what I was meaning on doing was check out minus b to memory, which does the same thing as that, the check out. But yeah, now we'll look at what we have. So we do that, we start using that second thing. So there's like quite a bit of stuff that we want to make sure we want to make sure that we don't overwrite stuff. So we only want to load this much max of our hard disk. So I might add a to-do of that. We will do that. So what I might do is source boot includes BIOS, read disk, disk read this one here. Fix me this shouldn't read past at and would start overwriting EBDA. This page. Yeah. And then we also want to add source memory and source that one. And that is that. Cool. Yeah, so we'll commit that up. Memory. Add start of memory mapping. This adds some more real node code to read the memory descriptors, which can then be used in predict mode. Ideally, the memory manager will allocate chunks of that RAM and then make all the cases some chunks rather than static memory. Note that disk read function should not let us read too much as it could overflow into EBDA memory usage. Boom. Yep, cool. I think that's good. And we'll make a new branch. So I think that's a decent effort for this morning. So it's something that I've probably been putting off for quite a while, dealing with memory properly. Who would have thunk? But yeah, this is a good spot to be in. And yeah, we can see that we have some sort of an idea on like what memory we have, and there'll be some cleanups to do. So I'll clean up the real mode code a bit to make it more aligned with my style, I guess, and have some like error detection. So if it doesn't find the memory, then I don't know, it doesn't boot. Because yeah, if we don't know how much memory we have, then we can't really go along with the rest of our operating system. And I'll also check that the disk doesn't overread too many things. That one might be a bit more of a pain because we can really read. We've only got a byte to spare, but some of the stuff that we do in the first sector we can shift into the second sector after we read that disk. Yeah, so that looks pretty good. So I guess I'll leave the video there, and till next time, let me know if you enjoyed watching this, and hopefully I'll get some more memory stuff done. And I've got a few other ideas coming up for the next release, maybe next release or two, which some of it is kind of side projects, some of it is related to the actual operating system. The side projects will kind of get merged in, but I mean, I'll put them all in the same code base, but yeah, will be useful in later steps, which I'll talk through when I do that. But yeah, until now, until then, have a good day. or evening or whatever. So yeah.